No, those aren't ammunition shells. Those are CO2 cartridges. D2DNY, real world HVAC simplified. Today, I've got a big unit here with a VFD drive, variable frequency drive. That's defective. And this VFD drive is for my supply fan. Okay, so it's defective. I have the unit powered down right now, as you can see. You know, here that is. It's down. It's off. Because I'm here working, and you can see the power, the size of this wires. You know, high voltage, all that stuff, just to be safe. It's powered down. I got the wires disconnected. These 3 wires go into my fan motor, and I'm going to show you where that is in a minute. Hold. Okay, so here's the motor. It is a big unit. All right, look at it. It is a monster. I could climb in this thing. Hold on a second. Hold on. Okay, so here I am. I am actually standing inside of the unit. That is how big this thing is. This thing is huge. So here's the fan motor. This is the evaporator fan motor. And I'm going to bypass that VFD drive, so this supply fan or evap fan going to run. Some temporary cooling in here. Here's the heat exchanger for the heating section, or heating chamber. This is a big unit. This is a mammoth. All right. So I'm gonna get back out of here. All right. So the return fan is in here. This section right here, over here. The return fan is back here. And I'm gonna go show you that real quick. There you go. There's your return fan. All right, let's get back to the good stuff. But to give you an idea, here you go. Look at that. These are the units, the scale of these units. They're big. They're huge. And I'm walking in the beams right here. All right. This one is bigger than this one. This one has 4 compressors. This is a 40 ton, I believe. This is a 20 tons. 20? Maybe 30 tons. 30 tons, 40 tons. Right? It's a big for a 40 ton. A 20 ton. This is a 30 ton. 30 tons, 40 tons. Okay, let's get back to the good stuff. Here are the compressors right there. 4 of those bad boys in there. Condenser section. Okay, so as I said, those CO2 cartridges, and you know, I was blowing out the fans for the VFD drive because the alarm was heat sink temperature high. So initially I figured I'd blow out and clean out the heat sink, which is in the back right here. It's in the back over there. That's where the heat sink is. Okay, that's the heat sink, and the fan is in the bottom. It sucks air in, blows it over the heat sink. So I figured I'd clean that out with the CO2, but that didn't help. It's still in fault, so I'm going to go ahead and take these wires. These are going to the motors, which I already checked. You know, I homed them out with my tester, and they're all closed. All 3 lines are closed. Our windings are closed, no open windings, and they are not grounded. I didn't do a meg test or a mega test. I just use a regular standard ohm meter. But I'm not worried about that. If that is the issue, we have the overloads over here. So when I do connect it directly, bypassing the drive, if there's any issues, it will trip right here. Okay, so I'm not worried about it. All right, this one goes for this one. Is it? Nope, that's wrong. This one goes with this one. This is the return. It says return fan right there. And the bottom one right here is the main blower, or supply fan, or evap fan. It goes by many names. Alright, so this will trip if there's a problem with the motor. No worries. So stay tuned. Let me go ahead and move these wires over here, and I'll get back. Okay, YouTube. So these wires were so big, you know, I was up here fighting with it. I was wrestling with these wires. These wires are so big. So what I ended up doing, you know, it's almost like good luck getting it connected over there. So I had cut off one of this. This is the main power coming into the drive. And here's the remainder of the cut-offs. I cut all them all off. Figuring out at least once this failed, wasn't able to do that, I figured I'd cut them off and use these wire nuts, the gray. Still, these wires are so big it still wouldn't fit in these wire nuts, and that's the biggest I had. So I decided to remove and sort from the starter. All right. So basically, from the starter, I'm going back into my motor. All right. So there's power on this side. This activates whenever the system starts up. So then bypassing the drive and send power directly back to my motor. Now these wires was on the starter, and they would take the main power from the starter, bring it back into the VFD drive, and then to the motor. So sort of like right now we cut out the middleman. All right. Also, I had one of the power wires, you know, one of the wires going to the motor, one of the wire goes through the CT switch, current sensing switch. Less we'll have an alarm. Perhaps we're going to still have an alarm because this unit, it looks at the static pressure, and if it's too high, it will be stuck in startup. So I'm going to have to probably meddle with that, you know, just to get this thing to come out of startup, or leave it in startup and just manually turn two of the four compressors on, and leave them on all the time. That's it. It's a temporary fixed. Okay. So let's fire this up and see what's gonna happen. Okay, powering it up. But what I want to do, I just want to bump the fan. So I just bumped it, and I want to go over there and see if my rotation is good. And yeah, it's spinning. All right. And I don't know I think that's the wrong rotation. Yes, it is the wrong rotation. It's supposed to be going up, but it's going down. All right. You see the arrow right there? That arrow. Oh man. Okay, my thing is out of focus. See the arrow? That's that arrow right there. Shows the rotation. It's supposed to be going this way, up, and right now it's coming down. You see that? It's going the opposite, wrong rotation. So I'm gonna go ahead and fix that. It should be rather easy to fix. And you know how did I bump it? Basically, you just manually pushing the contactor like that. Manual. Alright, so let me go ahead and fix it. And to fix the rotation, basically you interchange any two leads. I won't mess with this one because this one goes through the CT and it's already tight. I'm gonna use these two up top here. Alright, so stay tuned. Okay, so now my rotation has been fixed. I'm gonna go ahead and power up this beast. I'm gonna go ahead and power the beast. Okay. I'm gonna go ahead and bump it once more. Push firm and hard. Okay, let's go see what we got. Once again, you must be warned. My videos are real time. Oh, here we go. I didn't even get to see if it was going in the right rotation. Let's go kill power real quick. Double check that. It should be good, but I like to double check. Yeah, so like I was saying, my videos are real time, you know, no editing. The most I'll do is pause the camera while I record, because I have to put it down. You know, I can't work while holding onto the camera. So sometimes I gotta pause the video, just pause it, put it down, so I can do what I have to do. But it's real time. Once the video has been done or completed, I'll upload it straight to YouTube, no editing, because this is hence the reason why it's called real world HVAC simplified. So look at the motor right now. It's a centrifugal fan, by the way, if you're wondering. You got different types. You got squirrel cage and centrifugal. This is centrifugal. And let me pause this, because who wants to watch this boring thing? Okay, now you could see we're going in the right rotation. All right, so I'm gonna go close this panel up and go get some compressors running. All right, so I'm back at the controls. Just reapply the power. There you go. So the fan is turned on. That's the main fan. Now the return fan. Come on, focus, man. What's going on with you? Okay, the return fan is not on as yet, because the supply fan is on only by the main power starter. Okay, so the return fan still have to wait for the controls to go through its phases. But it is important, but it's not that important. I'm gonna go ahead and it's still saying system on startup. This display is going bad as well. It's a bit broken. You can see part of it, but it says startup. That's the system status or unit status. It's in startup. I know this thing because I've worked on it several times. This is the back view too. So I can go ahead. I know these are my compressor outputs. So 4 compressors. You know, I've labeled these as well. Some time ago, some years ago. But I'm gonna go ahead and just manually put on compressor number 4. So that's on, and compressor number 1. All right, so I got 2 of my compressors on manually. I could leave that like that indefinitely, not indefinitely, but you know, I think that's what I'm gonna do, because these even though I put them on manually, and here's the selector switches right here, all the way to the right, that's auto, in the middle that's off, and to the left that's on, manual on. In auto they will turn on, you know, based on controls, you know, based on whatever the system is looking for. But even though I did that, the safeties are still intact. If the pressure is high, it will cut off on high. If the pressure is low, it will cut off on low. You know, the safeties are still intact. Let me see if I could get a temperature reading. And this thing, this needs to be replaced as well. Let me so we have an alarm here, I'm certain. And I know what's gonna be, but I don't care. It's 95 degrees on supply here temperature. It's hot. Space is hot. Alright, so let this thing run. I'm going to just pause this video, wait for it to go through spaces and the temperatures to go down. I'm probably going to put a few more compressors on just for the hell of it, just to bring the space temperature down. So now I got all 4 compressors going. And my fans are running as well. Okay, so I got the fan going, compressors 1 through 4 on, and then they all trip and freeze protection. Now that basically, this particular unit, the freeze protection or the non-freeze is basically low pressure. All right. So when the low pressure goes off, that comes out, comes up as freeze protection. But what I found is that here is a supply. That's the heat exchanger. Well, this is a supply, right? The supply here goes down into the building from here. And when I look down, all the dampers, the fire damper is closed. It's dead shut. Wow. Multiple problems, man, I'm telling you. And it's hot on this roof right now. Let me climb in here and show you what's going on down there. Okay. You see that? That's the fire damper in the main trunk line. And I don't know about you, but clearly I can see that that damper is closed, man. It's closed. Yeah. Look at that. I don't think this unit, it does have a section of the supply routed through the panel, the control section. Supply here goes through and the return here comes back around. I don't think this having a relationship to do with why the drive was off in high heat sink temperatures. I just think that the drive was just old and it's time for it to be replaced. Because I've cooled it down and you saw how many CO2 cartridges I had on that thing. I blow and I blow. The alarm was still there. And it wouldn't allow the fan to start. So now I gotta go find this fire damper inside. Yeah, I'm probably gonna have to do another part to this. But it's pretty much straightforward. I'm gonna have to replace that drive. I'm probably going to recommend replacing the return fan as well, because it's pretty much the same age. This is an old unit. It's R22 and these compressors, right? It is R22. Yeah, it is R22. See right there, refrigerant R22. How much pounds per circuit? I don't know if it shows the manufacturer's date in there. Oh yeah, minimum clearance, compostable. I don't know. It just says 9/12/05. All right. I'm assuming this had to do something with the manufacturer's date, right? I think so. Yeah. 05, 2020 is 15 years. Yeah. This thing runs every day, so even Saturdays except Sundays. So there's a lot of mileage in this unit. A lot of miles. So I'm gonna go ahead and hunt that fire damper down. Man, it's hot as balls up here. Look, I'm sweating in my arm. And it's pretty much straightforward. Once the damper is opened, then I can give them temporary cooling. I could probably, more than likely, I'm gonna leave 2 compressors on all the time. And once again, it's fine because the safeties are still intact. By doing that, it's just going to cool the space down. Won't get it really cold because it's only 50%, but you know, the customers will be happy, the client will be happy. All right, if you like this video, give it a thumbs up. If you haven't subscribed, subscribe and smash that bell icon so that you'll be notified every time I upload a video up onto YouTube. Again, this is D2DNY, Real World HVAC Simplified.